think we'll get started. So welcome everybody. Today we'll be reading Amazon's Chronos paper that they published, I think about a month ago now. I'm Sally Ann, I work on the product team here at Arise. And Amber, do you want to do a quick intro?
Yeah. Hi, everyone. My name's Amber. I'm an ML growth lead here at Arise. You probably see me a lot on the community side. I do a lot of conferences, events, and workshops. Also create a lot of content. So if there's any content that you want to see in the generative AI space, you could just message me directly in our Arise community Slack. I'm always looking for kind of like new ideas or what people are interested content-wise.
Amazing. Yeah, as Amber mentioned before, if you have any questions as we're going along, feel free to drop them in the chat or the Q&A. We'll be peeking at them as we go, and we'll definitely try to reserve some time at the end for us to go through them. Before we get into our paper today, I did want to do a little announcement about our in-person conference, Observe. It's happening July 11th this year. We're going to be in San Francisco at Shack 15. Really super cool venue. Excited for that. We do have a special promo for all of you joining today. So you can use promo code Kronos to get 50% off the standard ticket. So really great deal. Sarah's going to drop the link in the chat for you all to register. So come join us. It's going to be an awesome event. Cool. All right, so for today's agenda, we're going to do a little time series 101, just a really quick refresh of what the current landscape of time series is. Then we're going to go through the Kronos framework. Amber's done a really awesome test on Kronos versus Arima. They share stats in the paper, but it's always fun to kind of try it out for yourself. She also has a lot of different anecdotal kind of research that she's done to see what people are saying about it. So we'll get into that. And then we'll have an overview of our founder research, Aparna, who's done a lot of research on can LMs do time series. So we'll walk through that in the end. But at a high level, what we're trying to do today is understand, does Kronos, does LLMs, do they have the capacity to kind of be the gold star for time series models, or will these traditional models kind of continue? So if anybody's familiar with Greek mythology, this is what this is taking inspiration from. So excited to kind of walk through it today and see what we find out. So time series 101, I thought it was important, maybe people haven't touched really time series since, school, or maybe have been sticking with the same model for a long time. So I just wanted to kind of call out some of our classical models, deep learning models. So for our classical models, these are usually called local models since they independently fit, that unique model for every time series. We have ETS, ARIMA, Theta. These are kind of commonly used forecasting techniques. I'd say ARIMA is probably the most popular. It's a really reliable model that folks seem to love to use. And as I note there are really effective for those series with clear trends and seasonality, which is going to be important when you're dealing with this kind of wild time series data. There are deep learning models that exist and are used. These are more like global models because they're going to look at the multiple time series in the data set. They're going to capture those complex patterns and relationships, and they're really powerful in those environments with really large data sets. So classical models analyze each time series independently, while deep learning is going to look at the whole data set. The output is very similar for both. So classical models will usually focus on predicting the precise value, while deep learning is going to provide that density function of future values. So just kind of a TLDR on time series. I think it sets the scene well of what the benchmark is that we're comparing against. And with that, let's get into the Kronos. Oh, sorry. Forgot about this. LML Base Forecaster. So something that's interesting is I feel like this paper is getting a lot of attention. I've been seeing it a lot more than some of the other papers that have come before it. So in case you're not aware, LM Base Forecasters is something that's probably, or not probably, is a really hot research topic right now. So there's a lot of people in the time series community who have been kind of using the same model. We've been using Arima for years. It's reliable. And as soon as LMs came on the scene, they're like, what does this mean for time series? So some of the approaches we've seen before are pre-trained LLMs to forecast through prompting. So if you've ever heard of Promptcast, Comcast is a way to prompt, a pre-trained LLM to look at time series. We're making the numerical data strictly textual and passing it through the prompt. But then there's other series of research that focus on adapting LLMs to time series via fine tuning. So this is LLM time LLM, GPT-4 TS. And so these are basically the two main approaches we've seen so far. The challenges with this is it requires a lot of prompt engineering, specifically for that first approach. You got to get your prompt really well positioned to be able to actually get accurate results here. If you're doing the second approach, it's going to take a lot of fine tuning. Like each new forecasting task requires you to fine tune the model, and that's just kind of really expensive in a lot of different ways. And then they're, resource intense. So they depend on large models, which are going to increase computational demands, and then it could have prolonged inference time. So these are kind of the growing interests, approaches, challenges. And then I think the key thing to call out here is where Kronos is a little bit different than this is the fact that the Amazon research group had the realization that LLMs and time series forecasting kind of share a similar goal, and it's to decode sequential data patterns to forecast future events. So that is kind of the cornerstone of all of this research and what inspired them to kind of go and create this Kronos framework. Amber, before we move on to the framework, anything you want to add?
Yeah, definitely. And I think with what a lot of people say in the time series community, a lot of statisticians like, you know, this tabular use case is kind of like the last frontier for deep learning. And kind of the differences between looking at like a purely statistical like method and like time series forecasting versus something that has content understanding to it. So I think with what we're seeing with large language models is, and like especially like RAG use cases, is this ability to add context. And then you're making things like content specific. It's like, okay, the LLM's actually understanding what you're trying to get from it. It can provide explanations on it. And so I
Mhm.
think a big thing with time series, and Sally Ann and I will get more into this, but Sally Ann, from your perspective, like the format versus content debate, where do you see kind of like LLM forecasters fitting into that?
Yeah, it's tough because like with normal time series models, that like the idea of adding context, be able to add that additional context, maybe knowledge that you know about the data, is not something you can do with like a REMA, right? So it could potentially be a really, really powerful thing to give, to just have the edge over those traditional use cases, because that's just not something that will ever work for that. So I think context could potentially be the real secret to all this, the secret sauce, if you will. I see a lot of potential with that, and I think that's common with a lot of LLM use cases. That ability to really frame the data in a way that gives the LLM more context is just really powerful.
Yeah.
Here's what you think, though.
Yeah, no, definitely. And I think maybe like that could be on the horizon. It'd be amazing to have a time series model like explain, oh, we're predicting actually a drop here because I don't know, maybe like weather patterns that
Yeah,
reoccur like every few years. I remember like Walmart Labs coming in and like talking about how they sell out of strawberry Pop Tarts every time there's a major storm in like certain areas. And so that they need to kind of stock up on those. And they wouldn't even have realized like that was part of their model until someone like very specifically looked at it. But if you ask an
yeah,
LLM to explain, like, give me five, kind of interesting facts of like things we have to stock up on that we don't normally stock up on. I think that would be like really interesting.
yeah.
And yeah, we'll get more to the results, Sally Ann, because I think right now we're not obviously there yet. We're still trying to build forecasters to compete with things like
Yeah.
Arima. But yeah, let's show them how it works, Sally Ann.
All right, let's get into the framework a little bit. So this is a visual that's right from the paper here. It gives a really high level overview of how all of this works. So I think the idea that, time series predicts sequential patterns, so do LLMs. Like when I read that in the paper, I was kind of like, I had like a duh moment. Because I had been kind of playing around with this. We've had some colleagues who have tested it. We've tested it, like the idea of like prompting an LLM for time series, and it just feels so weird to like try to take time series data and like format it as text and send it to an LLM. It just felt wrong, and I wasn't ever surprised when it performed badly. But when I saw Amazon's approach to this, I was like, oh, that actually makes so much sense to take this approach. So what they do is essentially we have our time series data. We're going to do mean scaling. Then they're going to quantize it. And don't worry, we're going to get into that in a little bit more detail. And so from this quantization, they can then get our context tokens. So this is going to be the actual tokens that will then pass for training. So for training, they use Google's T5. And then that's going to get, these predicted probabilities and, that next token ID, which is essentially that forecasted value. At inference, something very similar happens. We take that context token, except we're going to get, the sampled tokens. And what's interesting is you have to then dequantize and unscale to get back to our forecasted value. Because you remember in the beginning, that's how we're training. So you kind of have to reverse that to get back to your ultimate prediction. So this is a high level. We'll kind of break down these steps in the next few slides, but really interesting approach, and we'll kind of make it more clear in the coming steps. So the first thing I mentioned was scaling. Different scaling approaches you can take. They use mean scaling here. So the data scaling really helps keep its shape, but it restricts it to a smaller set. If you think of LLMs, that's going to be important, less kind of range for the LLM to have to kind of attend to. So this is a really important step in it. So this is kind of a visual comparison. You can see this is just kind of some generated data. I did use GPT-4 to help me generate some data here to plot this out. It's a secret weapon. But yeah, you can see the number of purchases just as an example here, plotted over time. We're ranging pretty high range, 30 to 70, and now we're kind of through those discrete values there from the scaled time series data. So just that range is decreased from 0 to 1.4 instead of 30 to 70. So super important. Then the next step is we're going to take that scale data and we're going to quantize it. So there are, again, different kind of approaches you can take here, but what Kronos does is it takes the scale time series data. So that's kind of what we're visualizing up here. And then we're going to create a time series of fixed tokens. So they're using percentile binning. So the tokens can really only go from 1 to 100. And the really key point of both of these tasks is it makes it easier to represent the values as the fixed set to the LLM. If we skipped all of that, it would just be a lot less performant. So these are really important steps. And as I mentioned before, they'll kind of come back in the end to reverse this process that they did.
Yeah. And Sally, we have a brief question. I know you're kind of in the middle of it, but so someone asked, they understand tokenization of words for vocab. Can you elaborate a bit on kind of the tokenization of time series? Maybe just a little example of I don't know, if you're given prices, how that just gets tokenized through these steps.
Should we go to the paper maybe? I think there's a good example of it in here. Let's see. Where is it? Sorry, y'all. Let me see if I can find it.
Yeah, no problem. Yeah, while Sally Ann looks for that, yeah, I feel yeah, the tokenization of words has become so logical to us. And the sequence is already understood because it's whatever context that sentence is put in. And yeah, looking at it, and this is also why LLMs traditionally aren't very good for regression tasks because of how difficult it is to create context or meaning behind just numeric values.
100%. I think what we'll do is I know there's a visual in that paper somewhere that I'd love to show. When you're showing your research, I'm gonna find it and then we'll circle back to this question at the end.
Okay.
Just because I think it would be helpful to show. Okay, perfect. So we'll circle back to your question soon. Oh, well, I'm clicking the wrong direction here. All right, so just kind of breaking down everything we did in a little bit more. So it enhances the traditional language model frameworks by kind of exploiting that sequential similarities between the language and time series models. So these are the core components. We just talked about the scaling and quantization, but excuse me. One thing that I thought was really interesting in this was the fact that Chronos doesn't take any of the temporal data into consideration. And I feel like that's something that, traditionally is super important for time series, but for Kronos, it ignores all of those indicators. Um, Amber, I'd love to kind of hear your thoughts on that because I know you spent some time playing around with this. Any ideas on the differences that could cause between Kronos and your traditional like time series models?
Sorry, which part, Sally Ann?
Oops, the temporal features, the exclusion of that.
Oh yeah. Right. So I think this kind of goes to use case as well, where oh, I do think Kronos did a better job than some previous like deep learning time series models where they're using like only really like benchmarking against other deep learning time series models. But if you have a use case where it's like I only care about a forecast that's going to have like an hourly component or a daily component, like take Chick-fil-A for example, like they're closed on Sundays, and so they don't really need something that's going to include Sundays in the prediction because they're not going to have data for it. If you're looking at things that are purely like, oh, like say Kronos is really good at predicting month over month like sales, that could be good. But if I'm a machine learning engineer and I don't care about month to month, like I need it on a much
Sure.
more granular scale, like then I'm not going to use it. Or if I care about seasonality or if I don't have trends, like very use case specific here. Um, and so it, we might get like LLM leaderboards for time series LLM models.
Yeah, it's a really interesting approach. I think we'll get into that a little bit more later on about like what use cases and what the unknowns are too for this model. Okay. For training, I think I already mentioned this. They use Google T5. They do employ categorical cross entropy loss. So that we're really viewing forecasting as a classification problem to learn these distributions, which is again very, very interesting approach here. Kind of turns like everything. I feel like if I back in like undergrad and grad school when we learned about time series, if we were told that it was going to be turned into a classification problem, my brain might have exploded. But um, it's the world we live in now with these large language models. Another really important call out for the training is that they actually enhance training diversity using TS Mix and kernel synth. I think this is a really, really important thing to call out because we see in some of the research that our founders have done, have other people have done of like how important it is to kind of have diverse training sets and try to your best to make sure that the training data sets are not the same as like the benchmarking marking data sets, so that when they have those zero shot forecasting for that new unknown data, it can actually perform. So it's great to see. These techniques are really interesting. I definitely encourage you maybe to check out the paper and see exactly how they do that. TS Mix blends scaled sequences from existing series, and then kernel sync creates synthetic series from Gaussian processes. So it's really interesting to see how they employed those, and that's how they got their training data set. For the forecasting approach, the model is fed sampled context tokens and generate a sequence of future tokens. That was that last image here in that visual we looked at before. And then these are dequantized and unscaled to get the final prediction. So, they do all of the scaling to kind of get the tokens into these like finite values. And then we kind of have to disperse that so that we can get back to the original data set that we're looking at. So, really interesting approach there. So that's kind of the Kronos framework at a high level. So I'll pass it to you, Amber, and we can get into um, the research that you've done, get
Cool.
into understanding how it performs.
Yeah. We also have like a few
Oh, do
questions.
we?
So let's maybe like have a bit of a discussion here. And then Sally Ann, I'll also have the paper up. So if you find that example. We can show that example that Nikesh asked about. So Abbas asked, is Kronos good for intermediate time series? Like some of these questions, I think just like I'll show how to play around with it. Um, I bet if you ask the Kronos team versus someone that like does intermediate time series, like the answer may vary. I'm sure you could get it to work for it. Like I'm showing kind of uh two different examples for just like the granularity of the time that's being looked on. Jazz asked, would it work if you have missing slash nulls in the data sequence? Sally, did that come up at all for you? I know like missing data and nulls, like there are ways to get around it, obviously with traditional techniques and kind of like uh smoothing or different like EDA approaches. But not sure if you kind of came into like contact with like nulls in the data sequence.
Yes, they employed pad, I forget what it was stand for, but they essentially had this like pad time series of different lengths to kind of replace any missing values. And they used also end of sequence tokens to like denote that end of the sequence. So I think those two techniques that they mentioned in the paper are probably how they overcome any nulls in the data there.
Awesome. And then Farid, well, he pretty much mentioned something that we're going to talk about more, but for this is absolutely correct. So the training data is quantized, been forecasted to become a classification, which Sally Ann, like you mentioned, like that's not definitely not how we were taught for time series analysis, but that can mean that you're not going to forecast like not novel values.
Yeah.
And that's very true. And it almost goes a little bit with Pawan's question of, is it valid for multivariate time series?
Mhm.
Which, it's interesting. Um, because I think like what like some discussions are saying is like if you apply deep learning and apply this like LLM like layer, it could be good for like multimodal. So it's going to be
Mhm.
less good for traditional things, like things that you really like doing with traditional statistical time series forecasting. Like I don't think these techniques should try to beat time series at its own game. Uh,
Yeah.
but in terms of research and in terms of just like expanding capabilities, that's really what it's about. So there are some big claims for like these like LLM time series methods, but most of the time the claims fall short of traditional methods. But and this is what we were discussing, Sally Ann, like there could be additional methods and different things that you could get from using something like this versus traditional. It's not going to be
100%.
less money, we can say, to use these methods.
Yeah,
All right.
it's really interesting. I guess just to kind of just clarify that last question we got of like how does it become a
Yeah. Yeah.
classification problem? So you talk a bit about their objective function there, and how it really works is they're essentially trying to minimize the cross entropy between those different distributions of the quantized round truth in a sense. So it's like performing regression like via classification, not like just a full classification problem. So I would say that that's essentially what it is. So they're explicitly trying to recognize um, like just the cross entropy between them. It's not trying to see like this bin is closer to this bin. It's just trying to kind of understand that distribution there. So hopefully that adds in a little bit more clarity to how it's doing it by classification.
Yes. Awesome. Yeah. I realized that was a question and not a comment. How you said that, Sally Ann.
No
Um,
worries.
awesome. So So Sally-Ann just went through kind of the tokenization, the training, a bit on like the inference, like the processes there for how they're tackling it. Again, this is kind of the next steps for these like the language of time series, if you will. And so what I did, and anyone could go to the Chronos forecasting GitHub, and the first thing I want to do, which we talked about this and like how to read AI research papers effectively, like once you understand the paper, once you can compare the techniques, the audience is already asking really great relevant questions like for their own use cases and traditional use cases that they've seen. The next step is to just start testing those. And if they don't provide the ability to recreate their own experiments, I just don't believe anything really that goes on in the paper. The paper like put out by the team. The Amazon team did put out the model, so you can run your own benchmarks. But yeah, anytime someone's talking like up their own results, either reproduce them or wait and see if someone else in the field is going to produce them for you. I am running GPUs. So this, I would say this, I did try it on a CPU. It worked the first time, and then I ran out of like space. So if you want to run this, I would recommend using a GPU for it. You don't need the GPU for the ARIMA versions of the experiment. For Kronos, they have these different models. Obviously, they talk about the tiny one, which is 8 million parameters, and the large, which is 700 million parameters. It is pretty amazing that we do have models this large for time series. Like like 5 or 6 years ago, like I would not expect models this size for time series, and it's still, still being more and more effective. So it is really cool to see this research being done. I used the small here, so 46 million parameters. And the example they had was like passengers, how many passengers like on I think passengers on the plane like over time. But this was just the example data set they created. And so it's like this is passengers over a time period. And you see obviously a trend. You see the seasonality, you see like an increase. And it's saying like, can Kronos, the small model, predict this next peak for it? And so it does do a good job. Now, again, this is the example that Amazon put in the GitHub notebook. So first step, being able to recreate what Amazon showed. And so, okay, I could recreate that with what they're showing. The next step is comparing it to a different data set. A popular forecasting open source data set is the Walmart sales forecasting data set. There's a lot of really good work done on this on Kaggle. I believe it was a Kaggle competition. I got this data from this GitHub notebook. This person really dives into like this notebook is huge with workflows, machine learning workflows, and kind of traditional data cleaning and time series techniques. So if you want to run that, you can. I just kind of ran the results for it, but not computationally dense. Like you can run this notebook yourself. So looking at the Walmart data, essentially we just care about the weekly sales forecast over time, which looks like this. So you do have some periods of like, negative sales, not many. Walmart is making a lot of money, and this is like, I think 2012 data. So like upwards here for just the idea of the range. So let's predict, the next, I think I have it as the prediction length of just 25. If you want to expand it further than a prediction length of like 60 points, it's going to break. So just note that. So maybe predicting like the next 25, 50, like that's fine. And a good number of samples is like 10 to 30 samples here. So I ran the forecasts, and just to get an understanding of how much data compared to what's being forecast, this is the forecast amount. I'm going to zoom in, but just so you understand like how much compute is going into predicting the next like 25 points here. It's a lot of compute to get at this prediction. Now this is now this is over a long period of time. This is each week over, I think, a few years for the data here. And so when we run Kronos, like from like this is the very end of our data. When we run the Kronos predict, it actually looks pretty good. So when just looking at it anecdotally, it's like, okay, so it actually does a decent prediction. Yeah, the prediction interval might be a little high if this is, essentially this is the money, the value for sales. So, it's definitely like within those bounds, but it looks pretty good. But then we have to actually compare it to reality. And so when we overlap the actual data, the difference here is like half the sales that were made in this time. So for the compute, for the process, um, it's fine. But when when we run the ARIMA notebook just to see like how close this is, these are much higher numbers with, I mean, the actual versus ARIMA it's pretty crazy. And if I smoothed this out to be like kind of like the actual like residuals, it would be very, very close. So this is just kind of a little example, a little toy example of, just some real world data. Overall, Kronos would not win the Kaggle competition. This is, I think,
Sad.
the main thing to say. And yeah, like Sally Ann, if there's anything we want to get into here, otherwise we could either go back to the paper or talk about some even talking about some of the discussions around Kronos. So there was another GitHub repo, which I didn't have time to run through, but I saw it posted. I believe this is Nixtla, is the company, and pretty much they found that, Kronos is like 10% less accurate and 500% slower than training classical statistical models. You can run these experiments yourself. They did provide the notebook. Haven't been able to go through this, but a lot of people agree that, hey, it's going to be a lot slower. Mostly these models are about fast imprints.
Mm-hmm.
And then the accuracy, we kind of just saw like, yeah, that's probably at least 10% less accurate.
Yeah, totally. I can actually, this is kind of reminds me, I have a slide of kind of
Oh
community
yeah, absolutely.
impressions of like this is my new favorite segment. If you were here for the Quad 3 paper, Amon and I started kind of pulling things from the community, and I'm really excited to have these because I think it just gives a really good pulse, and I think it calls out some of the things that I keep doing that we put. So one thing, I think this is kind of shown in the sentiment of some of the questions we've gotten here. This person says like, am I missing something? Because we tokenize text because it isn't numbers. Now we're tokenizing numbers into less precise numbers. Like, what is going on with this? I thought that was a great call out because at first it kind of seems like kind of counterintuitive to do this. So kind of countering my initial remark was this makes perfect sense. So I thought that was interesting. There is one specific. Oh, this one was really classic, I think. It said, they thought that what they really should have said in this paper was we used LM techniques to see if time series forecasting better. So far, not really.
Not really.
Amber's results showed that perfectly. Yeah, this is the real one I was looking for to show. So this person calls out the fact that like you get comparable results, but like the resources that you have to use. So trading in like the CPU based approach for, GPUs and these massive models, like from a cost perspective, like that just doesn't seem realistic. And I think that's kind of a point you were just getting at, Amber, is like they're just so large and it takes so much and it's going to have latency and all of this. So it doesn't really feel like we're quite there yet. Something that I also thought was interesting was somebody called out the lack of interpretability. That's something that always sticks with me because right now we don't have like true explainability for these large language models. We really don't know exactly how they're coming to their conclusions. So when you have a lot of money on the line, like you typically do with like a forecasting use case, choosing a model that you can't really interpret is something to me that definitely stands out.
Mm-hmm.
And yeah, this is also an interesting call out where I think it counters everything that you and I have been saying, which is for some people though, if you can pay a price to get better results, they'll do it. So just really interesting mixed results from the community. But I just wanted to call out the GPU comment since that was kind of your note there.
Yeah, no, that's exactly the like kind of four takeaways that I had written down from people. That's, less accurate, slower, less interpretable, and more money. Like the interpretability is really, I think, a key area because with stats, you can essentially derive what's going on from what you're seeing and know how each thing is predicted and like why it's predicting that. And I think, that's where research could get really cool around language models because like the same way that you could ask a data scientist to say what's happening here and they have to figure it out. An LLM could do that when provided the data. So it's not going to be interpretable from a like statistics perspective, like not from a derivation perspective where you can go in and figure out why this is happening. It can be interpretable from an observability perspective, like where you can ask the model why it's predicting an increase or why it's not increasing or decreasing at all, because maybe it's like,
Yeah.
well, if we just stay here, it's a safe bet, and understand like why it's actually making those predictions.
Yeah, that's a totally good call out. I know we only have a few minutes left. We do have a few more questions. For the question about how we do time series tokenization, I couldn't find the visual I thought existed in the paper. I thought there was one. But the scaling and the quantization that I was discussing in the beginning, that's just the TLDR on how it's done. So we're taking those infinite values and through the scaling and more importantly through the quantization, that's how we're getting those fixed values of tokens. So I typed that out there, but hopefully that clears things up. Let's see, we have some in the Q&A. How does Kronos compare with Google's Times FM? That one, I don't think I didn't come across that in my investigations and while reading the paper. Amber, did you happen to come across Google's Times? They mentioned a few that just wasn't one of them.
Yeah, I was looking at that one. I didn't see any specific mention on that. We pretty much saw like Lag Llama was very poor performing, and was it time? The time one was performed pretty well. GPT time GPT. Some
GPT-4 TS. I think
yes,
it is.
all these names. Yeah, so but a lot of the like this is coming out now, like kind of these benchmarks against each other. And again, use case specific. Someone asked about, is there a way to put in features to improve the Kronos prediction? Sally Ann, you looked
I
excited.
think I think that's kind of the question that you and I were chatting in the beginning of like the whole idea of adding context. And so I think they didn't really explicitly say that there's a way to add in features, but when I hear that, I kind of think of adding more context to the prompt. So in theory, I think it's totally doable, but love to kind of hear what your take on it is.
Yeah. Yeah, it's interesting because the example, and I think someone also just asked for like, is there like another example to show. I could also, I'll send out this notebook to the community. But the example they showed was just like a prediction of number of passengers over time, which was like a perfect time series sequence. Like, it had pretty perfect components, and I couldn't find like where that came from. I don't know if it was just generated, but like that's essentially an example, and it only had the one features. So would more features help? My guess would be yes. Like there's so many time series examples of leveraging features, especially features that have that seasonality component, which help with your
Yes.
predictions. Um, but yeah, like I mean, this one was a zero shot.
Yeah.
That was like kind of the whole point. It was zero shot. So I would guess any like additional like thought methods would help, and any additional features or content would help with the prediction.
Yeah, it would be interesting with some of those prompt-based like prompt tasks, like kind of comparing that and playing around with the prompt that's used there and comparing it. I wonder if that could be a good test for us to see if that theory does edge out without using it. Um, Cool. I think the last question in the Q&A at least is what exactly gets assigned a token? Is it one point or a sequence of data points? I think you're referring to kind of like that initial context token that gets passed into the model, and that is going to be the whole sequence of data points. You can kind of think of it as when you're prompting ChatGPT, tell me something, and then it's going to kind of predict the next token based off of your initial question there. We're doing the same thing, except we're taking time series as our prompt in a way, or our initial input, and then we're predicting the next token, which is a data point from there. So that's kind of how it works. So we do the scaling and the quantization to get our token, and then we're predicting the next token that is then dequantized and unscaled to get that final value. So that's a
Yeah.
little bit more on that process there.
And like if you play around with the model yourself, you can select that prediction length, like how much you like how long essentially of a sequence you want predicted from your examples. And you can select, you can probably, change that window size, or the number of because you could put in the number of examples, and you could put in the prediction length, and so you can also chunk essentially like that data. I haven't played around with that, but yeah, it would be interesting to see, like, because it correctly predicted like the next sequence for the example they had with those passengers, like number of passengers. But if it was only given like the half a sequence,
Mhm.
like, or sorry, half a like a period, um would it be able to do that? Like if you stopped at the last amplitude, would it be able to do a full prediction? Which I really don't know. um
Yeah.
but that's an interesting question, and that's why I think there's so much research around it as well. Overall, we have 1 minute left. Like overall, Sally, and like what are your takeaway thoughts from Kronos?
Yeah. I feel like I'm gonna share my screen one more time. I uh should have kept it up here. But my final takeaway is really the fact that no, I do not think, is it sharing? I can't get it to work. No, I don't think Kronos is going to reign supreme right now. I think there's a lot of work that needs to be done in kind of this field to understand how we can more, I think, efficiently really leverage LLMs. I think they're just way too costly. The performance isn't edging out something that's kind of simple and straightforward that everybody's been using for a really long time. So it's exciting. It's fun to see these new models and new applications come out. But it's definitely not there yet, in my opinion.
Yeah, I agree. I think I'm glad we read the paper. I'm glad we experimented with it. I think it's really cool seeing all this research being done by teams that can afford like all the computation costs, and they're
Yeah.
putting out research on it. So it's really neat to see the claim of like it not sacrificing accuracy. I don't believe that. I think accuracy is sacrificed compared to traditional methods. And it really all depends, when you see these papers coming out, look at the benchmarks being used.
Yep.
Because right now, It's really cool research. I love seeing it. Do I recommend people change out their forecasting models with something like this? No, but if you have the compute, you could play around and see.
Absolutely. Yeah. And I'm going to post one more thread. It's our Parna, our founder, did more research on LLMs. And I think she has a TLDR there that was like, nope, don't trust your stock prices with LLMs. So read that out if you want more context. But yeah, Amber, I think you summarized it perfectly.
Awesome. Thanks, Sally Ann. Thanks everyone for joining. If you have additional questions, you can ask them in our Arise community Slack.
Absolutely. Thanks, everyone.
Thanks,
Have a good day.
everyone. Bye.